Okay, cool. That took a while. Hi, this is Permacomputing in Python. This is Duffus Castle in Scotland near Elgin in the north. I highly recommend you go and see Scotland. It's quite beautiful. I didn't expect it, but like it looks like Elder Scrolls in real life. It's awesome. You should go. I'm Łukasz. I come from the internet. Well, actually, I'm from Poland, which is very far from here. I used to live in Vancouver back in 2013, 2014, and I'm actually moving back here relatively soon. To do this, I'll have to leave my job at the Python Software Foundation. I'm currently the C Python developer in residence, but a US profit will not be able to immigrate me to Canada. So my sponsor, Meta, agreed to take me on as a full-time employee to make that happen. I won't be disappearing from the Python community. I won't be disappearing from what I'm doing right now. But I'll be a full-time employee of Meta again. I used to work for Facebook a long time back. So yeah, that's the news. You heard it here first. And I also run the Core.py podcast. We're sorry we have not published in a while, but Pablo also has a new job. So a lot of changes in 2026. Once I'm back from this conference, we're going to record a new episode. It's going to be about async functions. So it's going to be interesting. You can follow that to know what's happening in CPython. What are we talking about today? We're talking about permacomputing, which actually is a term that originally comes from permaculture, which is this sort of term coined in the late 70s to talk about organizing human habitats and growing food and all sorts of other things in ways that mimic successful systems in nature. And those systems have a bunch of features that make them essentially permanent. That means like they are regenerative, right? That they are sustainable and that they are adaptive. So permaculture was this sort of grand concept about like making sure that we are not destroying the planet we live in. And the European Union actually employs a lot of the permaculture rules now in what they require, like biological, which is the term in the EU for organic food to be produced and so on. So it is not just like a philosophical term that, you know, it would be nice if we did. There is actually practical things that people are doing with permaculture. So yeah, like the concept actually stresses collecting resources that peak abundance, you know, self-regulation, so you don't take more than you need, responding to feedback and change, and actually using small and slow solutions that connect to one another rather than like huge solutions that are less flexible that way. And it works by eliminating entirely waste. Well, with digital computing, with digital technology, we cannot actually do it without waste. So permacomputing instead asks us to recognize the inherent value of the hardware and software we already own and to make sure that we can use it for as long as possible. Because, you know, all the devices, all the components and materials we already have, like they had to be mined, they had to be processed to like make into the systems, the solutions that we have today. And to this end, permacomputing focuses on minimizing obsolescence and superfluous upgrade cycles and superfluous maintenance, you know. But even well-built and well-maintained hardware and software will fail at some point. So permacomputing will talk about how to be ready for that because this is pretty much inevitable. But for us to have a productive discussion about like, well, what all of this means, like I have to preface this with just saying that if you're worried that I'm gonna advocate for you to move to a remote part of Scotland, get off grid and sell your smartphones and all the other devices, like this is not that talk. I'm not actually a radical. I just believe in user agency. This is very important to me. So some materials on permacomputing will describe it in radical terms like, and I quote, an anti-capitalist political project driven by anarchism, decoloniality, intersectional feminism, post-Marxism, degrowth, and ecologism. Cool. I will say that like, I'm not particularly keen on romanticizing communism by people who never had the misfortune of living under a real communist regime. So let's just focus on practical notions of sustainable computing. And the longer I'm part of this industry, the more I think it's a core issue for us, because we're still like a really young industry, but like at some point we're gonna have like more garbage and more like old school systems than new ones, and what then? So it is just a matter of time that this becomes an urgent issue. It's already an important issue, but like the urgency will catch up to us. So yeah, I said, care about user agency, and like we can lose it in many ways, right? Like it can be taken away when devices you own can be made inoperable remotely. Sure, like you might receive a refund, but you just lost your capability that you were depending on before, and you created e-waste, so that's not great. User agency gets taken away when your data ceases to be available to you, and yeah, you can migrate, but you have to migrate. It's a big inconvenience, and you know, sometimes what companies do, like to actually make you, to force you to do that, like are decisions that are hard to understand by individuals. Because like in this case, like Mozilla just essentially pushed Pocket on people that were actually unwilling to use it, but it was almost mandatory at in Firefox at some point, and then they shut it down. So, you know, inconvenience. But what if you did it like 300 times, right? So there's an entire website called killedbygoogle.com, and on this like front page, there's like 3 things that they shut down that affected me personally. So obviously, they didn't do it for irrational reasons. It was a business decision. They started a project, and they were running it, and they figured out that like either the business model just doesn't cut it, or the maintenance costs are like too high, or the legal risk is too high. So they shut it down, sure. But because of this, like it is highly disruptive to users of such systems. But even if all the business decisions were always aligned with the needs of users, well, the universe is actually pretty good at forgetting stuff. Entropy is manifesting in so many ways. So yeah, like it's not just business decisions. Let's talk about like old sort of wide timelines to see that happen like on a grand scale. Something I kind of like to visualize and show to people is like, look, like those continents here are colored and so nicely so you can recognize them when we move 66 million years back. Now, like, well, it no longer looks like Earth. And you know what didn't exist yet at that point? The mountain range Alps in Europe. That, you know, the pieces right here did not crush to each other like to form that mountain range yet. So there was no Alps yet. But you know what wasn't on Earth anymore? Dinosaurs. They were already extinct by that stage. And to this day, we only have around 100 relatively complete skeletons of dinosaurs. Like the species that ruled the Earth for millions of years, like 100 skeletons is not much, right? Like that just means the universe will just like deal with you to an extent where like nobody will be able to like recognize that, you know, there was ever a Łukasz Langa, you know, in the past. But obviously you're like, Łukasz, what are you talking about? 66 million years ago, like who cares? So let's talk about like more human-friendly time frames, like 100 years, right? Like everybody wants to live to 100, and this is the Centennial light at the Livermore Pleasanton Fire Department. It was actually turned on in 1901, so now it's like 125 years of it running. And it's pretty dim today. It used to be a 60-watt bulb, but now it emits only like 4 watts of light. And why is that? Well, because of a phenomenon called electromigration. That means that the actual molecules of metal inside the wire physically move when current is applied to them. This wire is like super thick, so like yes, they are moving, but like in the circuit is still operable, it still works, so that's fine. But imagine in chips. Our chips have like super tiny, you know, like metal conductors and whatnot. So in circuit boards and chips, this electromigration problem is way bigger because they have higher current density and obviously like the smaller conductor dimensions. So this is exacerbated by temperature as well. So I expect that like we're gonna see chip failures increasingly in time because of that problem. But yeah, like even 100 years, that doesn't really strike like imagination too much. But what about like 20 years, like the lifespan of like magnetic drives and CDs and like all of this stuff, like where you're putting your memories on. Well, this is a picture I took in 2010 of my then young family and my 2-year-old, and I lost it to bit rot because at some point some bits flipped, and now the JPEG is not recoverable. And frustratingly, I had backups, but I was backing up the corrupted image for a while because I didn't know that this is what happened. And by the time I noticed, like all the backups already had the corrupted image, so too bad. And that's like, yeah, like a span of 20 years. But even if you're talking about the span of 2 years, which is the sort of warranty period in Europe for hardware that you're buying, stuff can break relatively often, and sometimes by like silly decisions by even super mature companies. So this is a MacBook Pro from like 2005, 2006 era. It had a replaceable battery, and good, because those batteries only like worked for like 90 minutes, so that was useful to actually be able to swap them if you needed. And also they had this problem that like they bloated like really aggressively, so like, you know, kind of if you had this problem, like, yeah, you could actually replace it yourself. But that's not what happened to mine. What happened to mine actually stemmed from this design, but what failed was this little ribbon that you can see right here that connects the top case, which is the keyboard and trackpad, to the logic board. That little ribbon was like repeatedly strained by the battery that was on the bottom of the computer. So if you actually kept your laptop, you know, on your lap, that broke. And I thought, oh, okay, it should be easy to just, you know, order a part, should be 5 cents, right, for the thing. Turned out that no, all of this is like soldered so much that like you need to replace the entire top case for $200. So yeah, like I was happy to receive a new top case, but the one that I had before, all of that became e-waste. Not great. So this is how entropy actually kills us, like, and kills our hardware. But there's also unpredictability in human life. There's so much of it. And here, this is gonna become this sort of saddest slide on this entire talk. So brace for impact, because like, it's gonna begin with like a, you know, innocent question like, what if you died now? And you're like, what the hell? Like, it's a Saturday morning, the atmospheric river just ended, like, you relax, dude. Yeah, sure, but like, what I mean is, when my grandmother died, her children gathered to like, you know, see her belongings, like, you know, can actually figure out like what she left behind. And they found some items that they never knew existed. Some like super old photos, like kind of mementos from like a past life, you know, at a different geographical like place where she lived when she was a child and whatever. And those are like now important things, like that remind us of the wonderful person our grandmother was. What about your photos? If you went away, like, would your significant other, would your kids be able to access them? Now we are so scared of like getting hacked, scammed, and, you know, kind of being spied on, that everything is encrypted, right? Like everything is Face ID, Touch ID, everything is two-factor authentication. Are you ready, like, for actually leaving your digital sort of stuff behind to your, like, for your closed ones? I think most people don't think about this yet. And this poses a big risk, because it's not only about like cute photos and like memories, but it's literally about like access to like your like net worth in somewhere in some bank, and like, you know, your health insurance information and whatever. So, you know, kind of thinking about this is important, because there can also be a war, right? And like, well, is it probable that your friendly southern neighbor is gonna invade Canada? Like, well, like, it's not probable, like, but can you really 100% certain say that like that will never happen? Well, I wouldn't. I live in Poland. Like, we also have like a very friendly neighbor in the east that like everybody's like afraid of on like very reasonable grounds. So that can happen. And I can tell you from experience what that means is not you fleeing to somewhere else, because where would you flee? Is you just sitting and like just hoping for the war to like spare you and go away. But what that means in practice is you're losing internet connectivity that you can depend on, and you're using electricity that you can depend on. And what happens then? Like, can you still sort of access everything that you need to access on a daily basis? Can you still actually utilize your smart home to the extent that you want? Can you still perform your work? Can you still access all the things that like actually are important for you to get to a doctor, right? And so on and so on. So like those are just considerations that like, again, people very often only think about when it's already like the event already is happening, but it's worth thinking about this sooner. Because sometimes you have to flee home not because of war, but because like there was a flood, right? Or there's a gas leak like in a building next door, and like they just told you to like just leave for a week. And when you do that, sometimes that means like you essentially just had to like flee quickly, and you did not take any of your like documents or devices that actually provide your second factor authentication. And what then? So just thinking even about like relatively mundane reasons why you would have to like quickly move temporarily to a different place. How inconvenienced would you be if you lost access to all your digital devices? And what will happen if you never could recover them again? Like, are you screwed now? Like, can you still log into your one password if you don't have your backups that you kept at the same home that you just now lost? Like, there's considerations there, right? But also, I don't know about you, but most of the time where I lose data is because I did something stupid. Like obviously, yes, Git protects us with the ref log. Even if you do something extremely destructive, like you can get back to where you were because the ref log is amazing. But the ref log is not kept forever. So if you only notice that you broke your branch like weeks after, like chances are like you might not actually recover your work. And if you're using OneDrive, iCloud Drive, and all those other wonderful file sync services, guess what? If you make destructive changes to your files, they're going to be happily replicated to every device that you own. So thinking about all of those things like is part of permacomputing, is part of the fact that like you want your digital technology to be dependable and to be available to you like as long as possible, to like with user agency that allows you to depend on those things even if the manufacturers of those things no longer are interested in maintaining those solutions anymore. So if you got super stressed right now, don't worry. There is a really nice summary of like things that you can do as a reasonable person. It's less about like, kind of atomic apocalypse. It's more about like you fell off the ladder and like what now? It's a great book. I super highly recommend it. It sort of changes the mindset from like panic to just like organized things that I actually am in control of, and I can actually improve in my life to make sure that my family is safe if my airplane goes down, whatever. So I highly recommend it. The author sounds Polish. He lives in the United States now, I think. He's a hacker, like mostly known like from his SSH v1 exploit that like had a cameo in Matrix Reloaded. So he's famous. But yeah, the book is good. So now, principles of permacomputing. What are you even talking about in practical terms? Yeah, I'm going to tell you. But I'm going to do counterintuitive examples because I know I already put a lot of stress on you. So let's talk about music. Yeah, that's my CP300 stage piano. Love the thing to bits. It's from 2005. So yeah, I actually moved it with me to Canada when I was here in 2013. Then we moved it to California with me, and then we moved it back to Poland, and it's still fully operational. It's a tank. It's amazing. So the permacomputing principle there is designing for maximizing hardware lifespans. And you see here that this is a mechanical device. Things will wear out. It's just a fact of life. So what the Yamaha did here is you can open it up like a hood of a car. The wires run long enough for the device to be able to like actually be turned on in this state. So you can check whether your keys work fine, like, actually practically while servicing your instrument. I actually unconnected all of this, all of the keys here, like, so you can see how they look below. And I did servicing of it like a bunch of times already. And to this extent, even though this instrument is so long discontinued, Yamaha still sells like parts that you can buy to replace, to like continue using it. So yeah, great example. In fact, like I'm a bit of a Yamaha fanboy in many senses. Like, it's a great company, does motorcycles and like engines for speedboats and also grand pianos. Like, yeah, I love those guys. They also do synthesizers, and those synthesizers, like, beautiful, huh? From '89. I have 2 of them because I love them so much. But the thing is, I do believe that they will outlive every phone in this room. And the reason why, they're almost 40 years old by now, but like they will run for another 40 years, is that they don't use a single chip that does everything. They use a bunch of chips that are super non-complicated. That not only means they're larger, chunkier, so the electromigration problem is gonna be less of an issue, but also if one of those chips fails, it is relatively easy to find another old device to just replace that chip from, to source that chip from. But even if those chips already ran out, like they're so easy that with today's technology, we can have clean room re-implementations of those chips to just replace the failed part. And actually people like those chips so much for like their audio properties that they are unsoldering some of those chips like from early Sound Blaster cards and just putting them in the new devices that you can buy today to, for example, like connect to your MacBook and in DOSBox you can play like your Secret of the Monkey Island or other game from early 1990s and hear how it sounded with the original chip from, in this case you can see 95. It says 9526 because it was the 26th week of 95 when this chip was produced. Yeah, but I'm not only talking about stuff that is old. There's modern companies that like take this into account like very seriously. So those are devices by a company called Mono. They do like musical devices. So like the computer there is Raspberry Pi based Norns, and the controller here is called Arc. And again, there is an important principle of permacomputing here, which is computational frugality. Norns is from 2017. By that time, we had Raspberry Pi Compute Modules 3. Now there's Compute Module 5, which runs circles around the first compute modules of Norns. But still, the community has this ingrained like care about all user-based scripts for music to be executable and successfully running on even the oldest Norns computers. So that fights against the upgrade culture that like you need to still like buy newer things just to be able to keep running modern software. So this community actively fights against that. That like we want to be able to service even the oldest of the computers, even if you build your own today. Build your own? Yeah, because Monom actually treats openness seriously enough that you can easily replicate like the Norse computer yourself, and there's plenty of clones, and this one like called Shield XL, like a friend of Texas like made for me. Well, I assembled it, but like all of the actual hard stuff like he did. So yeah, like now that is actually running a faster Raspberry Pi, but like whenever I actually develop something for that computer, I'll make sure that it's gonna run on the old one. And same goes for the protocols in which like the controllers actually communicate with those computers and everything. Everything is open, everything is like very well like documented. So you can clone like the ARC controller as well. And this one in particular is not even running like the software stack of Mono. This is running CircuitPython that I made like to work on the RP2040 with 2 cores, which actually like makes the performance of it like quite like fantastic. So I can program my controller in Python and not in Lua like the rest of the Norse community. And it connects just fine. And that finally brings us after 23 minutes, right, to Python. Yes, there's going to be Python in this talk, it turns out. So every now and again, people ask me like, hey, but Łukasz, but why do you work on Python? Like, is it like last generation legacy software is like dynamically typed in slow, like, kind of Rust like all the way and, TypeScript all the way and whatever? Like, what is the thing about Python that is the most like important? What is the thing? So the superficially, like people are often gonna say like, oh, it reads like English, kind of it has significant indentation, so elegant, whatever. And all those things are true. But to me, the killer feature of Python is this. Is the fact that like you can debug your software, including in the deployed state. You can introspect it, you can interact with it, and the sort of author of the software that you're running didn't have to plan for it. It just works. You can just set a breakpoint. You can actually see what your software is doing, which is super helpful if you are now maintaining some home assistant, smart home from 12 years ago, and you want to make changes to it that the previous owner did not employ, and like now you are inheriting a house, like, and you want to make changes to it. Now you can. You don't have to worry about like actually following up with the previous owner about whatever changes they made and whatnot. So Python, fantastic for this. And to this extent, like you can even add things to your old software that the original sort of authors never intended for. And you can do it by just using the super vast like standard library that we have. So we have like gold format support for XML, HTML, CSV, SQLite. All of them sound super boring, but that's a feature. If something is old enough, like to be like actually executable and like parsable in your fridge, like it'll be amazing because you're gonna be able to interact with it and interoperate with it, like with other programming languages and so on. So Python lets you do that, and it has like pretty cool like networking capabilities too. And for stuff that like we don't have in the standard library, obviously the PyPI like gives us like essentially any format that is existing in the world we can parse with Python, we can use it in Python. In fact, like there's a reason why I put Pillow here. Like I think parsing images like would belong in a standard library. It would be cool if like every installation of Python could assume that you can emit PNGs and like read PNGs would be great. Especially like a lot of this depends on like binary components. But I talked to Hugo van Kemenade, the maintainer of Pillow, like, and he's skeptical. So like, you know, we'll need to convince him a little bit. But the reason why I'm saying this is that if something is in the standard library, you can just depend on it, and you can just use it 20 years later, and you know maybe pip install will no longer work for that particular Python version 20 years from now. So if it were in the standard library, we would just be able to always use it. But yeah, I mentioned networking. Async IO, pretty fantastic. I don't intend you to like actually read through this code, but it's real code that I use to like back up my pyscript.com, which is a website to share code like written in PyScript with other people. So I can back up like all my projects from pyscript.com using this simple script like HTTPX and a bunch of other stuff. And it saturates a gigabit link, no problem, with a single thread of Python. So, you know, it's like we have the capability to be like really performant with networking with Python. So all of this causes me to use Python for everything. And I'll give you some examples. Like this is my West term, like, and you can see bpytop here, and there's conch here, which is a shell that you can script with Python instead of like the shell scripting language that is terrible for so many reasons. So now I have Python, so that's amazing. And here actually like that little Mandelbrot text is valid Python code, which I thought like you would enjoy because it doesn't really look like Python, but it actually generates a Mandelbrot set too. So I love it. Anyway, the fact that conch is a Python shell means it's written in Python, and you know where Python runs? It also runs on Windows. So you can set it up as a default shell, like including in the Windows terminal, so you can now have the same experience between Windows, Linux, and macOS, which I think is mind-boggling, is amazing. Like, just think about it. Like, it starts a little slow on Windows, but once it starts up, like, you can just like use the shell just like any other shell, which I find amazing because I can just depend on the fact that like, oh, there's full capability of Python. I know exceptions, I know like loops, I can import stuff, like it is incredible. I can extend the shell using, you know, pip packages that I write or use packages that other people already used. It's amazing. I highly recommend you look conch. It's XONSH, it's weirdly spelled, but yeah, it's what it is. I mentioned Bitrot, that hit me at some point in the past. So I wrote a little piece of software that helped me actually avoid this since. It is just hashing all files in a directory and putting this in a little SQLite file. And what that does is if files changed, it will also see if the last modified timestamp on the file was changed as well, because that just means a file was updated, that's cool. But if the contents changed, they hash differently, but the last modified timestamp is still old, that means that something fishy happened, like that shouldn't have happened. And that actually allowed me to catch a bunch of events of Bitrot. And ironically, the one that happens most often right now is just cloud synchronization services, like, you know, just degrading your files. Like, so if you're thinking that doesn't affect me because I have Dropbox, like, well, it might affect you actually. I don't know if the problem is on the client side or like on the server side, like who knows? All I can tell you is that like I had a bunch of cases over the years with cloud synchronization services actually failing me. But what it fails me more is my memory, I increasingly don't remember stuff that I did like 6 months ago. Like there's so much stuff happening all the time, so I keep extensive notes. Obviously, I'm not insane. It's not 1.3 gigs of text. What I do is I keep like notes for everything in my life, and like I keep them in the text bundle format, which is our directories. You see, Markdown is the text, JSON is the metadata about the note, and there's assets, so you can have like attachments that are like images or audio or whatever else. That brings it to a gig. The reason I'm showing you this is that those are just regular files that you can pretty trivially format like and parse like from Python. I actually synchronize all of this between my devices, including this phone, with Git. That not only gives me synchronization, but full history. So if the last modified date on a note is today because I fixed a typo, I can still see like when was that note created and like what did I put in there, and it's like, oh, that's from 2016. Oh, I remember the context now, this sort of thing. But the access to your files physically for your notes is a superpower, because now like you can use a nice client for notes. I'm not insane, I'm not using like Vim to do it. Like I have this nice client called FS Notes. It's an open source application for macOS and iOS. So yeah, it presents everything really nicely. But because those are all just files, ultimately, I can then use a static site generator to generate my website, which is actually what I'm doing. Like, and Netlify does this for me automatically whenever I like commit something to Git, which I don't do. The automation in Python does. So every time I actually edit something, including on my phone, my website gets updated. I don't have to deploy anything. It's pretty amazing. I just use my notes application and my blog is updated. So I like this a lot. But the core message here is that you should be able to do this with any data that you care about. You should be able to just think about new workflows that you want and, you know, make sort of surprising little improvements in your life based on that. So for example, now with the LLMs, like with all of this new world, I am able to use like local like models on Olama to like ask it questions like, hey, can you find this note where I was talking about this thing? The reason it's important is that this is not a search that I can grab for, because some of the oldest notes that I kept are in Polish. So I don't even remember if like the thing that I want is going to be using the English words or Polish words. I don't know. And the LLMs are fantastic at it, so they're just going to find the thing. And they can apply tags that I forgot to add to notes in the heat of the moment. So they're like, oh, this looks like a journal because like it has like the sort of structure of a journal entry and with the date and everything, but you never actually add a tag journal to it, and so on and so on. So I have like a ton of like little workflow things that I can do. And I wouldn't be able to do it if it was just Apple Notes that keeps my notes hostage in a closed manner. So that's what I'm talking about. Like user agency is sort of important. So yeah, Python is great for permacomputing, but it's not perfect. There's issues. So let's talk about them for a bit. So first of all, Python is an interpreter language, right? And the dynamicism that gives us the debugging capability, including in the deployed state, has a price. And that price is the fact that we're doing pointer chasing all the time, like to just access an attribute on an object or an item in a list and so on and so on. Everything is by reference, and the reference lives somewhere else in the memory. And this lack of locality in memory like degrades performance. So obviously, people are asking like, how does that work with, you know, all this frugality of like using like as little energy as possible and being as fast as possible, as efficient as possible? Well, I think the sort of trade-off of being able to still maintain your thing and not throw it away entirely is worth it. But to this extent, we are, as Python core developers, very much invested in making performance better in the future. We're pretty close to actually getting free threading to a state where it'll actually be the default version in Python. Maybe not in 2027, but maybe in 2028. Like we're getting there. There's so much investment in this thing. So, you know, like it is already proving itself like stable enough and delivering on the scaling promise, where if you have multiple cores and this little thing has 10, like you can actually have wall clock time cut by a lot. So if you're like training an LLM, just having something sit and wait because a single threaded Python thing is doing its thing is a major energy consumption problem. So if you can actually cut even those times, That's great. And this is how Python gets faster. But it also gets faster like by the sort of efforts of the Microsoft team that like was there like for 4 years. Like they did a lot of optimizations, including the specialized interpreter. And those projects continue now. Like there's sort of increasingly interesting like things happening with the JIT and so on. So you should expect the performance of Python to be better in the future. And speaking of LLMs and whatnot, like are we responsible partially for the high energy usage of all this AI stuff? Like, is Python like part of the problem? What is going on? Well, my take on that is that like AI has clearly proven that is like promising, and there's things that you can do with it that previously were just like unthinkable, like impossible. But it's still, there's plenty of problems, right? Obviously, like it's still not actually safe to just leave it like to do stuff. There's still issues with, you know, like the ethics of, you know, model training and so on and so on. So I think we are still very early on in the story of like where AI takes us. And to this end, I think actually the thing that will help us is capitalism. Because at some point, all of those data centers like are going to be a cost that the companies will want to cut down. So the efficiency part, like making stuff faster and like cost us less, will come. But now, like we're still figuring out like what this technology can actually do for us. So yes, Python could be faster, but yeah, at this point, I think like we're not in this stage of research and development yet. Well, I also wanted to talk about packaging because obviously like packaging is almost like the sort of like default thing that people don't like about Python. It's so complicated and whatnot. And well, there's reasons for it, sure. Like the biggest problem like of actually just using packaging, even if it works as intended, is that you are opening yourself up for a big like dependency chain with its own calendar of releases, incompatibility problems, security issues, and so on. So you should always be wary of the fact that introducing a dependency, while handy, is now sort of introducing new responsibility to your project that you didn't have before. And packaging in general used to be pretty hard. So for you to even make your dependencies available on platforms that you don't run on, well, that used to be hard to do, so people avoided it. Now with CI build wheel, things are improving. You can use GitHub Actions or another CI solution to produce wheels to PyPI for platforms like that you don't personally use, but people might want, like iOS. Now you can actually emit iOS wheels and put them on PyPI. Beware actually gives you the briefcase project that allows you packaging your software for Windows, for Android, for like multiple ways. Like so, things are improving again, but they could be better, huh? I guess so. Another thing that people say about like Python being tricky is, oh, the releases are too quick. Well, I'm sort of responsible for that with the PEP that actually changed the recycle. But we are still making that better for people by extending the bug fix period from 18 months to 2 years. Doesn't sound like much, but it essentially allows you to upgrade every second release. And then still have like the full bug fix support the entire time you are using a Python version. So things are improving on that front too, especially that like people sometimes complain that we are not treating backwards compatibility seriously. That's false. We are thinking about it all the time. It's essentially one of the major constraints like of things that we can do with Python at this point. But the policy that we had for a long, long time originally suggested just like having 2 releases with a pending deprecation warning, then a deprecation warning, and then removing a feature. Now with annual releases, that's only 2 years. So we are now actually suggesting smearing that over 5 years. And if you see on the left, there's a soft deprecation section. And that actually just says, can you just deprecate it in a docs and not even emit a warning so that people can still use the old method name that is maybe not what we want people to use, but if the code is already there and it already uses it, why not? So we are treating backwards compatibility increasingly seriously because Python is a public good. All of those things actually make me think it is a uniquely positioned programming language for the needs of permacomputing, for the needs of sustainability. It is not only open source, but is also not controlled by any single corporation, which means it is creating a uniquely level playing field for whether your company is tiny or it's a behemoth. Like we have the same sort of rights and the same access to the programming language. So, final 2 things that I want to show you. What can you do as a consumer to make the permacomputing things like more like tangible and real in your life? Well, you need to test your backups if you have them, and if you don't have them, make them, and if you have them, also make offsite backups. You should own your hardware, software, and data. So choose solutions that give you access to your information and they don't tie it to you paying increasingly high subscription rates. You should question the upgrade culture. Like, I have a 5-year-old laptop right here and I don't intend to replace it anytime soon. It's amazing, and with its 64 gigs of RAM, I guess I should wear it as jewelry right now. Choose repairable products. Like, ironically, this MacBook Pro, yeah, sold the RAM, but like otherwise, it's pretty repairable actually. So like, there are entire companies now focusing on this aspect of like consumer rights, that like they will sell you parts directly and you can repair them yourself. So think about it when buying. Yeah, I'm not anti-subscriptions. I have backups that I pay for. I have some like, streaming stuff, but whatever. But if you have solutions where you can just pay up front and have access forever, that's preferable. And keep learning. Maybe you cannot replace a battery in a MacBook today, but you can learn. With YouTube, with everything else online, like, you can learn. The flip side is, well, we are also developers, so we are sort of responsible for making that world better for other people as well. When you're making a Python project, you will be in the best position to like be supported for us by us the longest if you start with the newest version available at a given moment in time. I already told you why. That's great, but that's also important for like data recovery. It's easier to recover from formats that have been known for decades. And yeah, like, I'm not anti-LLM, but if there's a solution that you can employ that is simpler, like, don't ask LLMs to do stuff that are like otherwise simpler. I know that inference is way cheaper than training, but it's still like pretty memory intensive and it's pretty resource intensive. That's maybe the most conservative and controversial thing that I'm saying here, but keeping things online makes an additional dependency on the user to upgrade certificates. So even if there's no security vulnerabilities, in a few years, the old certificates will not allow this old system to connect to servers anymore, because the new certificates on those servers will not look genuine to this old system. So yeah, like, if possible, maybe it doesn't have to be online. You can support development of Python in so many ways. You can file issues, you can make PRs mindfully, not with LLMs. And if with LLMs, you are responsible for those things. So yeah, like, keep that in mind. You can come to PyCon US. I'm hearing the hotel block there is still like wide open, like, so yeah, you should be able to just like book everything. They really need your support. It's a major component in making the Python Software Foundation work. And the interest, for whatever reason, I wouldn't know why, is less kind of exciting than in the previous years. And yeah, again, keep learning. You can actually be better about all of those things, like, in time, if only you care a little bit. At the same time, I don't expect actually individuals to change the world. Systemic solutions is what we need, but you are in the room when decisions get made. You can steer the tanker just a little bit to make the world better for everybody else. Thank you very much for letting me go over time. That was Permacomputing in Python.